I'm Joshua Bardwell, and you're going to learn something today. Remember this guy? This is the quad that I built with my very own J. Bardwell F4 flight controller in it. And a few of you have been asking, hey, when are you going to finish that up? You see, I finished the build, but I didn't finish the configuration. And the real answer is I've been waiting for something very special. I've been waiting for the right one to come along and tell me it's time. You just know when the time is right for Betaflight 3.3 has finally hit release candidate. And that's what I've been waiting for. I've already got a Betaflight 3.2 ultimate setup guide. It's time to update it for Betaflight 3.3. And what better quad to do it with than this one? Stay tuned. Betaflight 3.3 isn't even out yet. It's on RC2, release candidate number 2, at the time of this video. And I normally hold off on making videos about stuff that's not out yet, because then I make the video and stuff changes, and then I spend the next 6 months responding to people who are saying, that's not right, or why didn't this work? But, let's do it. I want to get this quad in the air. I want to show you guys Betaflight 3.3. So this is the Betaflight 3.3 Ultimate Setup Guide. We're not going to go through every single new feature of Betaflight 3.3. We're going to do a basic setup for this quadcopter so that if you've just installed Betaflight on your quad and you just want to know what steps you need to take, this is the video that will do it for you. So the first thing you got to do is you got to install Betaflight 3.3 onto your flight controller. We say flash it to your flight controller. And in order to do that, you got to get your drivers sorted out. And I'm not going to go through the steps of downloading and installing the drivers because I've got one video specifically about how to install the drivers. I'll put a link to it down in the video description. I'm going to reference a whole bunch of other videos because I've already made really detailed videos on a lot of these topics, and so I don't want to just rehash everything. It's not a good use of my time. It's not a good use of other people's times who have already sorted it. So the first thing you got to do is install the drivers, and down in the video description, go down there, click, and if you don't have your drivers already installed, then watch that video on how to do it. And here I'm going to get Betaflight Configurator, and you need to get Betaflight Configurator downloaded and installed. It used to be a Chrome app, Google Chrome, the browser. It used to be a Chrome app. Now it's a standalone app, and there's a standalone app available for Windows, for Mac OS, and for Linux. So you can go download that. I've got a video about how to do that. And if you don't have that, down in the video description, go get the the Betaflight Configurator. Then you're going to flash. So you got your drivers sorted out. Hey, welcome back. And you've got the configurator downloaded and installed. Hey, welcome back. And then you're going to go to the firmware flasher screen, and we're going to choose the board. Now, you need to know what your board's target is. And this is easy to do. I'm going to just show it to you right here, even though I also have a video about how to do that. What you're going to do is you're going to connect to the flight controller. And if this point that doesn't work, your drivers aren't installed correctly, you got to stop. You may have a problem with your USB cable. But see, I'm doing it. I'm getting off on a tangent. Go, just connect. You've already sorted that out. We're going to go to the command line, and we're going to type version. And here we're going to see version Betaflight, and in my case, it's CL Racing F4. That is the key text that you need. In my case, it's CL Racing F4. For you, it may be something else like Omnibus or SP Racing F3. You need to know what that text is. Then I'm going to disconnect, and I'm going to go to the firmware flasher screen. And in this pull down, I'm going to select that text that's known as your target. The target is what flight controller you've got, more or less. So mine is CL Racing F4. Yep, that's it. And I'm going to choose a firmware version. And in my case, I'm going to choose 330 Release Candidate 2. That's 330 RC2. If you don't see the release candidates there, what you need to do is you need to check this box, Show Unstable Releases. That'll let you download the release candidates. If it's a month from now, then you're just going to flash 330 because Betaflight 330 will be out. You won't need to use a release candidate. But at least initially, we're going to be flashing whatever the latest release candidate is. In this case, it's RC2. Now I've got full chip erase selected, And I've got manual baud. Oh, that you don't need that. Don't use manual baud rate. That's from another board I was flashing that needed it. Most of you probably don't need that. Full chip erase is selected. It's always a good idea to choose full chip erase, but when you flash a new version of Betaflight onto your flight controller, because if you just flash the new version and you don't erase your old config, you can sometimes get problems. Before you erase your configuration, if you've got a quad that's working, save your configuration, you silly. And you're going to do that by going connect and go into the CLI, and you're going to type diff and hit enter. And then you're going to hit save to file, and it will save out your configuration to a text file. Save that somewhere on your hard drive. Frankly, folks, I do a config dump or a diff when I first get a flight controller, or anytime I've got a working configuration, I save it out, because like, even if all you need to know is what target your flight controller is, that's good to have that information saved. And if you've got a working configuration, go ahead and dump it, save it out in your hard drive, and if anything ever happens to your quad, you won't lose it. So do that now, save that now if you haven't. If you're starting from scratch with a brand new board that's never been configured, it doesn't really matter. Okay, so I've got my target selected, I've got my version selected, and I'm going to hit load firmware online and flash firmware, and at this point, nothing happens. Nothing is happening. And the reason for that is that I didn't run the Impulse RC driver fixer, which is discussed in that video about drivers, but I'm going to go ahead and do that real quick. So what I need to do is I need to get my board into bootloader mode. Hang on, unplug, replug. I need to get my board into bootloader mode. I can do that by holding down the bootloader button on the board, or I can just go to the command line and type BL, which will put it into bootloader mode, BL for bootloader, and then I'm going to run the Impulse RC driver fixer. The Impulse RC driver fixer is an app that if you work with Betaflight, you should just have it on your hard drive. It should just be, you're just going to use it all the time. Like almost every time I flash a flight controller, I have to run it to fix the drivers. Yes. Okay, well, some comment. Who made this flight controller anyway? Some combination of this flight controller and my computer's drivers means that it doesn't like the command line option to put it into bootloader mode, but I've just held down the bootloader button and plugged it in, and now I am seeing DFU in the upper right. That is my sign that it is ready to be flashed. And if you don't see DFU, you're probably not going to be able to flash. Your drivers aren't fixed right. And that's a topic for another video, mostly. Okay, so now let's flash. And people say Betaflight is hard. I don't know what they're talking about. I'm going to load and I'm going to flash. There we go. See, it's working. No problem. This isn't hard. It's just there's only like 15, 17 steps you have to memorize. Branching tree of decisions. Drive a man to drink. Parents, cover your children's eyes for this part. Yay, Betaflight 3.3 is on there, and let's see the COM port. Can I just connect? No. I think I gotta, there we go. And I'm connected. And if I look up here, I can see the version right here. Betaflight 3.3, it says right up here. That is the correct version. So we are ready to begin with the configuration. And the configuration I'm going to show you is specific to the Joshua Bardwell F4 flight controller. Now, there are many parts of it that will also apply to other flight controllers, but some of it are going to be specific. I'll let you know when we get to those parts. The place I'm going to start is the Ports tab. And this is where we configure the peripherals that are connected to the flight controller. And the main peripheral that's going to be connected to this flight controller is the receiver, which is... No, that was a coincidence. Hold on. Is the receiver, which is on UART 1. A UART is a serial interface. Think of a UART like a USB port on your computer. Computer nerds who are having a conniption right now because it's nothing like a UART. It's got nothing to do with plug and play, and a serial port is... No, calm down, computer nerds. I'm one of you, but we have to dumb it down for the other people. Just breathe. Just breathe. A UART, think of it kind of like a USB port. If you got a bunch of them on the flight controller, you're going to plug some peripheral into them. In this case, we have soldered the signal wire from the receiver to the S-bus pad on the flight controller, and that is connected to UART number 1. Okay. And how do you know that? Well, you know that by, in my case, my flight controller has a super awesome detailed manual that gives you all this information. A lot of other flight controllers are going to have information online, or maybe a wiring diagram, or sometimes it's even silk screened onto the board, like the CL Racing F4. I really love what Chenling did with it. He actually put the UART numbers right there on the underside of the board. If you want to find out more about how to wire up a flight controller and how to understand what's a UART and what are all these pads and you're soldering it together, where does it all go, I have a playlist called Flight Controller Wiring for Beginners, which basically I think everybody in this hobby should watch that playlist. Because it tells you all the parts of a quad, how they're wired together, you know, and all those sort of major permutations on that. I'll put a link to that in the upper right. See, that's so important. I'll put a link in the upper right, not just the video description. Okay, yeah, check that out too. So on my flight controller, the receiver is on UART 1. UART 3 is going to be used for telemetry, which is smart port telemetry. And UART 4 I am using for TBS SmartAudio. That is going to be used for VTX remote control. That is used to let my flight controller talk to my video transmitter and tell it what channel and output power and other configuration options. I have separate videos on all of these topics. The point here is just to sort of go through the configuration of this flight controller and not get off on too many bunny trails about what all of this stuff is. Try to keep it tight. Next, we'll go to we'll hit save and reboot next. I believe I also have ESC telemetry, don't I? How did I frickin' wire that up? There's one more thing I need to do. I almost overlooked it, and that is I'm using UART 6 for ESC telemetry. Is that ESC right there? Yes, that's where it's going to be. Yeah. So I have BL-Heli 32 ESCs on this, and they're capable of sending data to the flight controller via a feature called ESC telemetry. They can send things like the motor RPMs or the current drawn by the ESCs, and that's configured here on the sensor input column. The UART that they're connected to is going to be set to ESC, and save and reboot. Now we'll move on to the configuration tab, and here's where a lot of the magic is going to happen. The first thing I'm going to do is I'm going to set up my motor protocol. The motor protocol you choose is going to depend on what your ESCs support. And for modern ESCs, even cheap ESCs, as long as they're made in the last 6 months or a year, or as this video ages, even older than that, they're going to be using Dshot. Dshot is a digital motor protocol that's used for the flight controller to tell the ESC how fast it wants the motor to spin. So most people who are watching this video, if you have a relatively new equipment, you're going to choose Dshot 600. Some ESCs can support an even faster protocol called Dshot 1200. Many do not, at least at the time that we're making this video. And a few of you out there are going to have older ESCs that only support either Multishot or even OneShot 125. Those are the major ones you're going to pick, and what you pick is going to depend on what your ESCs support. You're going to need to do your own research and find out what the ESCs that are on your build support. I'm going to pick Dshot 600 because that is what the best protocol that the ESCs on my build support. Next, I'm going to go down to the system configuration, and I'm going to set my gyro update frequency and my PID loop frequency. The gyro update frequency is going to be 8 kilohertz for almost everybody who's watching this video. If you have an older F3 processor on your board, if your flight controller has an F3 processor, you're probably going to want to select 4 kilohertz. And the PID loop frequency is going to be, if you have an F3 processor, it's going to be 4 kilohertz as well. If you have an F4 processor, which most of you probably do, you're going to choose 8 kilohertz and 8 kilohertz. Especially if you have an F3 processor and you need to, F3 processor is slower than an F4 processor. And you may need to save as many CPU cycles as you can. If you look down here where my cursor is, you can see it says CPU load 5%. The CPU is not very active. But if you've got an F3 processor, you may have a higher CPU load, and you may want to keep that below about 50% at most. You can do that by turning off the accelerometer. And what that means is that you will lose access to auto level modes. But you'll save some CPU cycles. And for many people who are racing or flying freestyle on maybe a 4 to 6 inch quad, you're probably not using auto level modes anyway. If you have a larger quad, like a 7 inch or 8 inch props, and you're kind of doing more cruiser style stuff, you may be doing auto level. Or if you've got a very small quad like a tiny whoop, you may also be doing auto level. So you'll need to leave accelerometer on. I'm going to leave it on because on an F4 board, I've got plenty of processor cycles. I don't need to really worry about turning it off, leaving it on. Doesn't really matter. I like to put a craft name on each of my copters. One thing, you can see this in the OSD and the on-screen display. Assuming your flight controller has an on-screen display, which many of them do, you can see it in the on-screen display, and it lets other pilots who are tuned into your frequency know who you are. In my case, as a YouTuber, I have a lot of quads. I like to put an identifier for the quad itself in the on-screen display so I know when I'm looking at an SD card full of video which quad I was flying. So I'm going to put my call sign and an identifier for this quad. And let's just put JBF4 since this is my flight controller, my unique build. That's how I'm going to identify this craft. Under the receiver type, most of us are going to choose a serial-based receiver. That is, if you've got a FreeSky, then you may have an S-Bus receiver. If you've got FlySky, you may have an I-Bus receiver. Or if you're doing Spectrum satellite Spectrum, all of these are serial-based protocols. A few of you out there may have a receiver that outputs PPM, which is an analog protocol, in which case you would select PPM RX input here. But for most of us, we're going to select serial-based receiver, and then you're going to choose the protocol here that is appropriate for your receiver. In my case, I'm going to pick S-Bus. For a Spectrum user, you're probably going to pick Spectrum 24.8. Spectrum 1024 is the older, like DSM2 or whichever one's older, DSMX protocol. The newer stuff is all Spectrum 24.8, or you can choose iBus, or those are the major ones you're going to pick. If you want to hear more about that playlist I talked about earlier, Flight Controller Wiring for Beginners, goes into great detail on that stuff. Here in other features, I'm going to tell you the features I usually turn on. I usually turn on air mode. I usually turn on anti-gravity, and I usually turn on dynamic filter. Now, I have videos about all of these features individually, so I'm not going to go into what they do here. I'm just going to tell you that I normally turn them on, and I suggest you do the same. Down in the video description, there's going to be a huge index of other videos you can go watch. Sorry, but there's a lot of information here, and I'm trying not to make this video be 45 minutes long. In this case, on this quad, I told you that I had those BL Heli 32 ESCs that do ESC telemetry. So I also have the option of using ESC Sensor feature. You may remember I turned that on in the Ports tab. I also need to turn that on here if I want to use that feature. I need to turn on telemetry. Telemetry is what's used to send data from the flight controller back to my Tyrannus transmitter. Telemetry is important because not only does it send data like the battery voltage back to the transmitter, so I can monitor my battery voltage, but also it's used, remember I mentioned SmartAudio. Again, SmartAudio is used for the flight controller to control the video transmitter, so I can change channels and so forth without having to go push a button on the video transmitter. With telemetry enabled, I can also do that stuff from my transmitter, so I can manipulate my transmitter to cause the video transmitter to change. There's a lot of moving parts here. I'm going to turn telemetry on. Oh, I got another one for you. Maximum arming angle. This actually did not used to be in the configurator on previous versions. You used to have to go to the command line for this. Your quadcopter has a safety feature that will prevent the quadcopter from arming and spinning the motors and slicing up your face if the quadcopter is not flat level on the ground. The idea is that if you're carrying the quadcopter in your hand, it's probably at an angle, and then the quadcopter will use the accelerometer to detect that and will prevent the quad from arming. If you should accidentally flip the arming switch on your transmitter, you know, like your transmitter's hanging around your neck and it's bobbling around and you're getting all your stuff, you're getting ready to go back to the car and you forgot to unplug your battery and then you bang the switch and blah, it flips out and chops you up and then you post a picture of your bloody face on Rotor Right. Don't do that. Don't do that. We don't need to see that. This is called small angle protection, and what it does if the quadcopter is not level, it won't arm. Protects you from that mistake. I like to turn this off because the problem with it is if you've got the quadcopter and it's like on a hill, or if it's on the starting block of a race, it's at an angle, it won't arm. And that can be pretty annoying. So I turn this off by setting this to 180 degrees. That disables it. If you do this, please be aware you are disabling a safety feature and you need to be more careful with your quad. You need to do things like set up a double switch arming or some kind of other protection to make sure that you don't accidentally arm your quad while you're holding it and cut yourself up, okay? That's your decision. You're a grown-up. You can make that decision for yourself. This is the power and battery tab, and this is where you can configure the voltage sensing and current sensing. So the flight controller has the ability to detect what the voltage is of the battery that's plugged into it. And this is useful because if the battery gets too low, then you will damage the battery or the quadcopter will drop out of the air. The battery voltage is reported in the on-screen display, and it's also reported by telemetry back to the transmitter, so the transmitter can shout at you and say voltage low or whatever it is, whatever it says. The current meter is also used to detect current drawn, so how much current like the motors are drawing, which is useful if you're a nerd like me who does a lot of testing and stuff. But it's also useful because it tells you the milliamp hours that are drawn from your battery, when milliamp hours are kind of like a fuel gauge for your battery. If you have a 1300 milliamp hour battery and you pull 1400 milliamp hours from it, you probably damaged it. So you generally want to pull about 80% of your battery's capacity. Voltage and current monitoring are useful for making sure that you keep your batteries healthy and you don't over discharge them. So this is where you can set that up, and by default it's set to onboard ADC, that's analog to digital converter, and that basically means that the flight controller has built-in sensors and you're just going to use those. That's how my flight controller is going to be set up, and that's how most of yours probably are going to be as well. You'll see if I use this pull down, I also have the option to use the ESC sensor. Because I have set up ESC telemetry, I also have the option to get voltage and current from the ESCs. The ESC current sensor is actually really useful because not every flight controller has a built-in current sensor. So if you have BLHeli32 or KISS ESCs that have ESC telemetry, you can get current sensing from them even if your flight controller doesn't have it. But in my case, my flight controller does have current sensing, and I've wired it up so I can use it. So I'm just going to choose onboard ADC for both of these. I can also adjust the battery scale. I'm not going to do that at this exact moment, and in fact, the default of 110 is almost always correct. But what you would do is you would plug a battery into your quad. Make sure your props are off when you do this for safety. And you would look up here, and you would look at what battery voltage is reported by the flight controller. And then you would get your multimeter out. If you don't have a multimeter, go to my Ultimate FPV shopping list. I'll put a link in the video description, as always. There's some multimeters there. Some of them are as cheap as like even $20, right? So you got to have a multimeter. You got to have a multimeter. You got to have a soldering iron if you're going to be in this hobby. So get your multimeter, check the battery voltage, and then verify that this is reading correctly. And if not, increase or decrease the VBAT scale to make it read correctly. And then the amperage meter. For the JBF4, the amperage meter needs to be set to a scale of about 250. There's a little bit of manufacturing variance, but you guys out there with a JBF4, you could just set it to 250 and you'll be pretty close to correct. And I've got another video on how to calibrate your current sensor if you don't have a JBF4. The default value that comes with many flight controllers is 400, which is not correct. It's not even close to correct. So you'll need to go ahead and follow the procedure in the video, linked in the video description, for how to calibrate that. Or your current meter will be way, way off, and your milliamp hours will be way, way off. And that's important that you know that, because you'll get a battery and it's, it's a 1300 milliamp hour battery, and you'll fly it to, 800 milliamp hours, your quad will drop out of the air and your battery will be dead because it wasn't actually 800 milliamp hours. It was something way off. So you got to calibrate this, and you always got to look at your voltage when you're flying. And if your voltage gets down to about, let's say 3.7, 3.6 volts per cell. So for a 4-cell battery, let's say around 14 to 14.5 volts. If you're getting down there, you're getting to the end of the pack. You need to land no matter what the milliamp hour says. Now, some of you do not see the Failsafe tab. You're like, hey, where's that tab? So what I've done is I have enabled expert mode. Expert mode, it gets rid of, by default, they hide some of these options that if you screw these options up, bad things will happen. But I turn on expert mode, and so can you. You don't have to be an expert. You just don't have to be a bonehead, okay? So I'm at enable expert mode, and in fact, what I like to do is go up here to these gear icon and permanently enable expert mode so I can always see it. Here in the Failsafe tab, I make a change to the Failsafe. You may want to leave the Failsafe at default. By default, when the receiver goes away, like for example, because you lost radio link, or I've also heard of cases where the signal wire from the receiver breaks. When the receiver goes away, by default, the flight controller will just kill the throttle, center the channels, and basically fall out of the sky. I like to set my throttle to hold instead of shutting down. And it's how long is it going to hold? Because you don't want the throttle to just stay up for an indefinite amount of time while the quad flies away into the sky. So the throttle will hold for 0.4 of a second. That's the guard time. And what I think there is that sometimes when I'm flying, I'll get just a fraction of a second of a fail-safe because I was pushing range, or maybe I have a damaged antenna and my signal's not quite what it should be, and I just I had a fail-safe there for a second, right? If you watch my video where I was flying at Hawkins Lab from the TV show Stranger Things, yeah, I went there and I tried to fly. I was getting fail-safe. So there's some examples of what a fail-safe looks like. Well, I don't want the quad to drop out of the sky the minute I get just a fraction of a second of a failsafe. I want to give myself just the tiniest bit of leeway. How much leeway? 0.4 of a second leeway. And then after 0.4 of a second, the quad will drop out of the sky. That's what this is. But I like to change the throttle failsafe from auto to hold so that I get just that little bit of leeway. Now in the PID tuning tab, I'm going to leave all the PIDs alone, and I suggest you do the same. PID tuning is a topic for a whole nother video, but the default PIDs should work very well for most people. And likewise, I've got a whole bunch of videos on PID tuning. I've got my practical PID tuning playlist, which is about 15 or 20 videos of PID tuning. And the one I suggest you start with is the PID Tuning Masterclass. Don't let the fact that it's a masterclass think, oh, I'm just a beginner, I shouldn't take a master. No. I just called it a masterclass because the guy who asked me to make it asked me to call it a masterclass. Go watch that, and it shows you what low gains and high gains and P versus I versus D. And I recommend anybody who's interested in PID tuning watch all of it. It's like 4 videos. It's maybe 2 hours total of content. Well worth your time. And I suggest you check that out if you're interested in PID tuning. Then you can go from there to my practical PID tuning playlist, where you can watch me tune quadcopters. And you could see me go through all the steps. And I'll tell you, start the practical PID tuning playlist from the last video, which is the most recent one, and work your way backwards, because the earlier ones are from like a year ago and they're still relevant, but they're not as relevant as they could be today. So leave the PIDs alone. I'm going to go to the filters, and you're going to leave the filters alone too. I have another video, on how to tune the filters, but for now you can just leave them at the defaults. I am, however, going to input my rates. I have certain rates that I use for all my quads. Rates are how fast the quadcopter spins when you move the sticks, and they really affect the way the quad feels. And I recommend that you set your rates the same on all your quads. Some people like to have low rates for racing and high rates for freestyle, but you're probably going to want to keep those the same to keep your quads feeling about the same, so your muscle memory about how to move the sticks stays the same. I'm going to set these rates up how I like them. Now, if you are smart, you bound your receiver to your transmitter while you were building your quad. But if you're like me, your receiver is stuffed inside your quad up underneath the flight controller, barely accessible, and you're going to have a hard time getting at your bind button to bind it. So I'm going to go take care of that now. Well, I just got done binding my receiver, and one of the first things I noticed was that I was not getting any telemetry in my Tyrannus. And it reminded me that there's a step you have to take for the JBF4 specifically, and a few other flight controllers depending on how they're set up. You need to go to the command line and type set TLM_half duplex equals off and save. And once you do that, telemetry should begin working. If you have been trying like the dickens to get your telemetry working on your JBF4 and it just won't work no matter what you do, that is probably why. That is in the manual, but I don't blame you if you missed it. It's kind of in one place and a lot of people overlook it. Now that I've got the receiver bound to the transmitter, in this case a Tyrannus X9D, you can see that as I move the sticks, the individual channels move and that's what I want to see. The first thing I want to do is I want to make sure that the channel mapping is correct. And what that means is when I move the throttle, does the throttle channel move in the receiver tab? When I move the yaw stick, does the yaw channel move in the receiver tab? Likewise for pitch, and likewise for roll. And not just that they move, but that they move the correct direction. Down in the lower right, you can see there's a little 3D model of a quadcopter, and as you move the sticks, the quadcopter will move. So you'll want to make sure that pitch forward makes the little quadcopter pitch forward, and so forth. And make sure all your channel directions are correct. Many people find that the default channel map is not correct, and what you can do is there are a couple of presets here, and you can just try one of these presets and see if it works for you. Or you can change the channel map, AETR, and you can see over here, AERT. Basically, the order that these letters come in control the order that these channels work. And essentially what you can do is you can swap those letters around. So if you need to swap your throttle and your yaw channel, you would change it from AETR to AERT. And basically you can move those letters around until the right stick controls the right axis on the quadcopter. Once that's done, the next thing you need to do is you need to check your channel endpoints and your channel centers. So what you want to see is that when the sticks are centered, right, you want to see that each of the channels is right about 1500. And you can see that I'm almost right at 1500. There's just a little bit of jitter in my sticks. See, this one keeps going from 1498 to 1500, but they're right about 1500. And when you hold the stick full on to one side, you want to see that the channel is at 1000. And when you hold the stick full to the other side, you want to see that the channel is at 2000. Now, I'm not going to go through the steps to do this. It's different for every transmitter. You're going to adjust the endpoints and the centers in your transmitter. I actually have an ebook that I wrote. You get the ebook by joining my mailing. So I have an email list where I don't spam you a bunch of spammy stuff. Every week or so, I send you an interesting article that I wrote. And you can get the ebook, which talks about how to do this. I wrote it all down there, so I'm not going to go over it again. There's a link to my sign up page to get the ebook down in the video description with all the other stuff. And if you want to get instructions for how to do that, that's where you can get that. But you need to see that the channels center at 1500 and 1000 and 2000 at either end. That's the most important thing. There's one more thing to do on the receiver tab, and that is adjust your stick low threshold and your stick high threshold. If you have adjusted your endpoints so that your sticks reach 1000 and 2000, then you can adjust the stick low and stick high threshold to, I like to use 1005, and 1995. Dang it, 95. What the key thing to know is that when you deflect the stick fully one direction, it must get below the stick low threshold, and when you deflect the stick fully the other direction, it must get above the stick high threshold. That's key, otherwise things won't work right on your quad. So if you for some reason can't get your transmitter to go all the way down to 1000, then you can adjust the stick low threshold to be just a little bit more than whatever your stick does get down to, and you'll be okay. Here in the Modes tab, you set up flight modes. And the most important flight mode that you're going to set up is the arming mode. The arming mode is how you use a switch on your transmitter to tell Betaflight that it should arm the quad and start flying. If you don't have an arming mode set up, as I don't right now, how do you arm the quad? Well, here's a little history lesson. Not too long ago, transmitters often didn't have more than like 4 channels. They didn't have a lot of spare channels. And the way you would arm the quad was by holding the yaw stick down, and I think it's to the right, and then down and to the left to disarm. But now, even cheap systems have at least 6 channels, so we should all have a spare channel to use to arm and disarm the quad with a switch. And I'm going to set up the arming mode. I have a video on setting up flight modes, which goes into detail on like how you actually set up the transmitter to cause the switch to control the aux channel. That's not what I'm not going to go into here. So there's down in the video description. But I'm going to set the arming mode up, and there's a cool new feature in I think it's Betaflight 3.3 added this, or maybe the configurator added it. So what I can do is I can hit add range, and then I can flip the switch to cause the aux channel to move. And it automatically picks up what aux channel moved when I flip the switch. So if you're not sure which aux channel is mapped to which switch on your transmitter, you can just flip the switch and it'll try to pick it up for you. And then what I'm going to do is I'm going to drag this slider down so this little yellow marker here shows the current value of the channel. So if I disarm the quad, you can see it goes up here around 2000. And if I flip the switch to the arm value, you can see it goes down here around 1000. And so what I want is I want this little slider to cover the position of the channel where I want the quad to be armed. I'm going to put the switch in the position that I want to be armed. I'm going to look at where this little yellow marker is, and I'm going to make sure this little yellow range here covers that, and I'm going to save. There are other modes you could set up, like if you're going to do auto level, you can set up a switch here to make angle mode be active. There's other interesting ones like flip over after crash. It's also known as turtle mode. Lets you flip the copter over using the props after if it lands upside down. There's various ones there. I've got a video on how to set up flight modes if you want to explore any of these. Here's the OSD tab, and this is where you set up the on-screen display. Now I'm going to show you briefly how to use this. Essentially, there's a whole bunch of individual elements that you can turn on and off. So for example, the RSSI value, and you can drag and drop them to set them up on the screen, and you'll see them on screen in your camera, in your goggles while you're flying. Now there are various ones that you can turn on or off. And you can just customize this any way you like. So some people like to have a whole bunch of like these horizon sidebars, make it look like your quadcopter's a fighter jet. I hear artificial horizon, yeah, fighter jet, right? I find that all pretty messy and I don't like it, but some people really like it. You can set this up exactly how you want it and just turn each element on or off and drag it where you want it. But here's a trick that I like to use. I save my flight controller configs to text files. Remember I showed you how to do that from the command line earlier in the video? And I've got one text file that has a few things that I do to all of my quadcopters. We call it the universal setup. And if I open up that file, I've got a bunch of the lines here. And you can see they start with set OSD. So what I've done is I set my on-screen display up however I like it to be. And then I'm going to go into that text file from the quadcopter that I saved out. So that I saved the config. And I'm just going to select all those lines that say set OSD. And I'm going to copy them. Because setting up the OSD can be pretty tedious. And then I'm going to go to the command line. I'm just going to right click and paste all those lines in and hit enter. And then type save. And this is a way how you can, if you have more than one quad, you can set the OSD up identical on all of them. Now if we go, to the OSD tab, you can see that the OSD is set up exactly how I like it. I didn't have to do a manual clicking and dragging. You only have to do that once, and then you just go and save those lines out and then paste them in. One thing I want to call out to you guys here on the OSD tab is this video format setting. This tells the flight controller whether your camera is using the PAL or NTSC format. If you know a little bit about old school standard definition television broadcasts, you know that in the United States and I think North America, we tend to use the NTSC format, and in most of the rest of the world, they use the PAL format. And the technical differences between them are really irrelevant for this discussion, but if the camera is outputting PAL and the flight controller expects NTSC, then one of the things that can happen is that your OSD can run off the bottom of the screen, or sometimes your whole OSD won't appear, or sometimes your camera will actually be blacked out and you won't see any image at all. If you experience any of those problems, go to the video format here and manually select PAL or NTSC. And if you don't know which one your camera is, just pick one and hit save, and then reboot the flight controller and see if that fixed it. And if that didn't fix it, go back and hit PAL and see if that fixed it, right? So just pick one then the other. But auto usually works, but sometimes it doesn't work. And that's a little tip for you if you experience one of those problems. Here in the Blackbox tab, we're going to set up Blackbox Logging. My flight controller has an SD card on board for Blackbox Logging. Some people will have a data flash chip instead. That'll be here in the pull-down menu. It'll say onboard flash. I don't have onboard flash, so that won't work for my flight controller. We're going to use SD card. I like to use a logging rate of 2 kilohertz, pretty much regardless. You can just set that and leave it. And that's going to do it for the basic setup of the Betaflight flight controller or the JBF4 specifically. there's a lot more little things that could be done to tweak it, and I'll go into more of those in future videos about Betaflight 3.3. But for now, the next thing to do is take your props off, plug in a battery, and arm the quad, and see if it arms, and then turn the transmitter off, and the motor should stop. If they don't stop, then your failsafe is not configured correctly, and you must not fly your quadcopter under any circumstances until you convince yourself that the failsafe is configured correctly. Okay? If you turn the transmitter off and the quadcopter motors keep going, or God forbid, rev to full throttle, do not fly it. It's gonna fly away. You're gonna be one of those guys who lost his quadcopter because his failsafe wasn't configured right. That's the first step. And then the next step is, you know what? I got a video on the next step. It's to check whether it flips out. And if it does flip out, I got a video about that. I got a video about all this stuff, but we got to end this video somewhere. So this is where we're going to end it. Thank you guys so much for watching. Welcome to Betaflight 3.3. It's awesome, and I'm going to keep covering it as it gets closer and closer to the actual official release. Looking forward to that. Leave me any questions, comments, or anything you think I overlooked down in the comment section below. Thank you guys for watching. Happy flying.